Now see here, in this case a particle P is initially at this point at t is equal to 0, which is moving in a circular path, that is here in clockwise direction. So, and time period of the particle is given to you 2 seconds and its amplitude A is equal to given to you 3 centimeter. Now, you have to find out the displacement for the simple harmonic motion executed by this particle. So, initially particle is over here. So, we can write phi naught is equal to pi upon 2. If you take its x component at any time, if it is moving in a clockwise, it will become x is equal to a cos omega t plus phi naught, that is the initial phase. So, we can write x is equal to 3 cos omega t plus, here this is pi upon 2, and that we can write here minus 3 sin omega t. So, this is here the displacement, or you can say the projection of the particle on the x axis. See here, a body is dropped in a hole drilled across a diameter of the earth, so that it executes simple harmonic motion. Assume the earth to be a homogeneous sphere. See here, earth is like this, spherical one. This is the center of earth, and now a hole is dug like this, one pole to another pole, and a body is dropped from this end. Suppose the body reaches to at this point after some time. So, this depth from the surface is d and remaining distance is r minus t, where r is the radius of earth. So, when the body is going down, acceleration due to gravity is decreasing. So, we can write here g dash is equal to g into 1 minus d upon r, and we can write g into r minus d upon r, that is acceleration due to gravity at this point. This displacement is y, suppose from the mean position, because this is the mean position. So, we can write g dash is equal to g y upon r. So, the force acting on this particle is here mg dash, that is mgy upon r. Now, this force is acting towards mean position, that is a gravitational force. So, that should be here actually restoring force. So, we can write F is equal to minus mgy upon r, that means F is proportional to minus y. So, you will be getting k is equal to mg upon r. It means this body will perform simple harmonic motion, because F is coming proportional to minus y about the mean position O, that is the center. Now, we can get the time period. We can get t is equal to 2 pi under root of m upon k. So, we can write 2 pi under root of m upon mg, r will be coming here, m will get cancelled, t is equal to 2 pi under root of r upon g. So, this is the time period of this body which is oscillating in this hole about the mean position O.